Good morning everyone. So students, in the previous class we discussed about the cells in the series combination. Yes. So today we are discussing the next part, that is the cells in a parallel combination. Yes. So what do you mean by the parallel combination then? See, we are considering the two cells like this. They are parallel to each other. Understood? They are parallel to each other. That's why we can say it as parallel combination. Or else the path of the current divides into the more paths. Yes? See, in the previous case we took like this. The path of the current is 1. Yes? In this direction only the current is flowing like this. Yes? But now in the parallel direction the path of the current will be splits like this. See, here one path is present, here one path is present. So there is a more path of the current in the parallel direction. Understood? That is the difference between the series combination and the parallel combination. Understood? So today we are going to discuss the next concept, that is the cell in a parallel combination. Yes? So again you consider the two cells. Consider the two cells which are having the first cell is having the EMF E1 and the internal resistance R1. Second is having the EMF E2, then the internal resistance R2. Understood? So now this cell, first cell is having the current I1 because this is having the one path, and this cell is showing the current, or else the current is flowing, that is having the value I2. Yes? Then the both will meet at the point B1, and at the towards the A the outflow is there. Yes? From the C the current is coming and it will comes at the point B2, and one will go like this and one will come like this. Yes? So the current moves upwards and it passes the first cell, that is I1, and again comes at the B1, and outflow will be the point A. And then the current which comes at the down, which passes the cell 2, and that is the current having the value I2, and again it will meet at the point B, and then it will move towards the A. Understood? This is the circuit diagram. See, if they ask you to derive the derivation for the parallel combination of a cell, then you have to draw the diagram first. Yes? Then again you have to explain this. What is the explanation? Simply you can write from this diagram. Yes? So what is that? Consider the two cells. Two cells are connected in a parallel combination between the 2 points A and C. So between the A and C we connected the two cells in a parallel combination, and those are having the EMF E1 and E2, and internal resistance will be R1 and the R2 respectively. Yes? So now I1 and I2 be the current leaving the positive electrodes of the cell. So I1 is leaving this positive electrode of the cell 1, and I2 will be the leaving the positive electrode of the cell 2. Yes? Then at B1 the current I1 and I2 flows in a way current I flows out. That means at this point this both will come and meet here, and it will become total current. Yes? Just consider here 5 ampere current is coming from this side, and here 2 ampere is going from this side. So what will it become? 5 ampere, 2 ampere, total 7 ampere current. Right? So both will be combined here, and it will become the total current. Understood? So now the total current I will be the current I1 plus current I2. Yes? Then let the V1 and V2 be the potentials at V1 and V2. So now we are having the 2 points. Here one potential will be there, and here one potential will be there. Yes, then respectively. So the PD across the terminals of the first cell is at this point. At this point the PD will be the, we are calculating. Here the at point B1 the potential difference we are calculating. How much? V is equal to V1 minus V2. Yes, how much we are getting? E1 minus IR1. So at this point EMF1 minus current into internal resistance of the first cell. Yes, similarly the potential difference at the point B, at point B2. Yes, so through the second cell. See, this is for the first cell potential difference, that is this much, and now the potential difference across this second cell, how much we are getting? That is V is equal to V1 minus V2, that is nothing but the E2 minus IR2. E2 is the EMF of the second cell and R2 will be the internal resistance of the second cell. Clear? Don't confuse with that. First cell E1 R1, second cell E2 R2. Yes? Now see, from this we can constitute the formula. So how? See, here just I will solve. See, V is equal to E1 minus IR1 it is. Yes, so take it as E1 minus V is equal to IR1, right? So E1 minus V divided by R1 is equal to I, right? So that only I written here. Take it as I1. Yes, correct? Here also you take it as I2 and here I1. Correct? So from this equation I took like that. That is the current I1. Yes? So see, first I took V is equal to E1 minus I1 R1. Later the E1 will be comes I2. This will comes this side and the V will be comes this side. So what will happen? E1 minus V, right? So later is equal to I R1. Then this R1 will be comes at the denominator and it will become I1. So we are getting the value how much? I1 is equal to E1 minus V divided by R1. Just understand how we converted. Yes, just we converted in terms of the electric current I1 and the I2. So similarly for this, so V is equal to E2 minus IR2, correct? So E2 will comes this side. What will happen? E2 minus V is equal to I2 R2. In order to remove this negative sign, I change the position of E2 and V. Yes, see here, V minus E1 is equal to minus I R1. So here the negative sign is there, no? In order to remove that negative sign, just I change the position of this. I made it E1 minus V is equal to plus I R1 plus I R1. Understood? Then we have the formula. Total current will be the I1 plus I2. Then put the value I1 plus I2. Yes. So here the common will be V. Yes. So what you will do first? E1 by R1 minus V by R1. Just split that one. Later E2 by R2 minus V by R2. Yes. So now what you do? Here E1 by R1 is there. E2 by R2 is there. So I will combine both the EMFs. So what it will become? E1 by R1 plus E2 by R2. Then minus, because at both the side the potential difference V is having the value minus. So I will take the common. Yes, minus V. So what it will become? 1 by R1. Correct? If I take the negative outside, the what remains there? E1 and R1 will multiply to E2. Cross multiplication you do for this and for this. Yes, and here also same. So what you will get? E1 R2 plus E2 R1 divided by R1 into R2. Then minus V, same, R2 plus R1 divided by R1 into R2. Correct? Then what you do? You take this minus V in this side and the current you send that side. So V, yes, it is a negative here. If that comes this side, what will happen? If that comes this side, it will become positive. So V R1 plus R2 divided by R1 into R2 is equal to, same you value put here, and this plus I, if goes that side, it will become the minus I. Correct? Then multiply and divided by R1 into R2 divided by R1 plus R2 on the both the sides. This side also and this side also. So what we will get? Like this. Yes? So how? See. If I multiply by this and divided by this, it will get cancelled. Correct? Then equal to E1 R2 plus E2 R1 divided by R1 into R2. Multiply and divided by. Yes? Then minus into I. What you will get here? V. That will get cancelled from that. Yes? Then what remains? E1 R2 plus E2 R1 divided by R1 plus R2. That only remains. Because multiply also and divided by also. So minus I. Yes? That is not having any value there. That's why we are getting here R1 R2 divided by R1 plus R2. Understood? So after this, if the parallel, take it as an equation number 1. If the parallel combination is replaced by a single cell between the B1 and B2 of EMF, E equivalent, and the internal resistance R equivalent. That means what? Since the series combination also be replaced by the one cell. Yes, that is having the EMF will be E equivalent and the internal resistance will be R equivalent. Yes. So similarly, here also we are replacing the two cells by a one cell. Yes. So I am removing these two and placing only the one EMF here. Yes. So that is having the EMF of E equivalent and the internal resistance of R equivalent. Understood? Next. So for this also we can write the potential difference. Correct? So potential difference is equal to the E equivalent minus current into R equivalent. Yes? So take it as a equation number 2. Now you compare the equation number 1 and equation number 2. So what you will get? Here also V is present, here also V is present. So easily E equivalent is equal to this much. Correct? Minus I. Here also I, here also I. Both will get cancelled. And for the R equivalent, you will get the value of this much. Understood? So you can write here E equivalent is equal to E1 R2 plus E2 R1 divided by R1 plus R2. Take it as equation number 3. Then for this, R equivalent is equal to R1 into R2 divided by R1 plus R2. So this I can write like this. Yes. So 1 by R equivalent is equal to, so you can write R2 plus R1 divided by R1 into R2 you will get here. Again you will take the cross multiplication. It will becomes the R equivalent. Yes. Just compare this one, both the equations. This is the fourth. Take it as a fourth equation and you take it as a fifth equation. Then divide the third equation by the fourth equation now. So third equation is the E equivalent and the fourth equation will be the R equivalent. So what you will get? Just consider here E1 R2 plus E2 R1 divided by R1 plus R2 whole divided this one I will change. Yes. So like first this one E equivalent I will write. Then it will changes. So what will happen? R1 plus R2 and R1 into R2. Understood? Just made the multiplication. Yes, if it is long in your mathematics, what you will do? You will write like that, no? Yes. So now this R1 plus R2 and this R1 plus R2 will get cancelled. So what remains? This much. E1 R2 plus E2 R1 divided by R1 into R2. So now for the, just separate it like E1 R2 divided by R1 into R2 plus E2 R1 divided by R1 into R2. Yes. Now you can simply write, see here also R2 will get cancelled and here R1 will get cancelled. So what remains? E equivalent divided by R equivalent will be the E1 divided by R1, E2 divided by R2. Yes, this much remains, no? Correct? So this is the formula for the parallel combination. Yes, when we consider the two cells in a parallel combination. Now we are considering the n number of the cells. So each cell is having the EMF S. So it will be E1, E2 up to so En. Yes. Then internal resistance will be R1, R2 and up to so it will be the Rn, because we are considering the n number of the cells. So every cell is having the EMF and the internal resistance and they are connected in the parallel combination. So now we are getting E equivalent and R equivalent for that, because for the every combination of the resistor we are replacing by the one cell, that is the E equivalent EMF and the internal resistance of R equivalent. So by seeing this we can write the formula, that is E equivalent divided by R equivalent is equal to E1 by R1 plus E2 by R2 up to so you will be take you as a En by Rn. Then 1 by R equivalent will be how much? 1 by R1 plus 1 by R2 up to so you can take it as a 1 by Rn. Understood? So this is the lengthiest derivation for the parallel of the cells in a parallel combination. Yes, it is a bigger derivation, but it is important for your exam purpose. So just you practice it in a paper, you will become perfect in that. Okay, so don't miss the one step also, because you will not understand the next step. So practice it, it will become easier to you. Okay.